Okay, let's move on to questions 3 and 4. So for question 3, it says, for each of the following declaration statements, determine how many bytes of memory will be allocated. So we're just using what we know about variable data types and understanding how many bytes are there. So for the first one, we have int day, month, and year, keeping in mind that we can declare multiple variables on the same line. They all have the same data type, so these are all ints. And we have 3 of them. Ints are 4 bytes. And we have 3, so that's going to be 12 bytes total. So that's 12 for the first one. Then we have a char star name ptr equals ampersand name. We can remember that for any pointer type, so if we have a star next to any type, it's going to be an address. That's what a pointer stores, and addresses are always 32 bits or 4 bytes on this system, the system that we're dealing with. So this is going to be a 4-byte value. And then finally, we have float, grades, and 30. So a float is 4 bytes each, and we have 30 of them, so that's going to be 30 times 4 is going to be 120 bytes. So not much more to that than understanding how large each of these data types is. Keep in mind, if it is a char without a star next to it, if it's not a pointer to a character, chars are the only things that are 1 byte. And so we would have to account for that if we see a char there, or an array of chars. Okay, so on to problem number 4. Problem 4 is asking us to fill out the stack, assuming that we've set a breakpoint at line number 12. So we're stopped there, which is the end of the program. We've run this up to that point using GDB, and the stack is shown. And so we're trying to fill out the stack as much as possible. We do have to sort of keep in mind that for one thing that we've run through this program, the memory doesn't go away from the function call. It doesn't get erased whenever we leave that function call. And so whatever happened during the tax credit function, right here, all of this stuff will still be there. And that includes the return address, prior EBP, all of that stuff would still be in memory. So it says a portion of the assembly language instructions corresponding to the main function are shown here. That'll be important for our return address that we need to find. And if we type IREBP, the result is BFFF31C. So really, we just have to identify that this is where EBP is currently pointing at our breakpoint. So that's the EBP for main. And that's what we can identify down here on our, next to our chart, is just specify that it's this. And I'm going to add one little diagram here that you have in your notes that I think is important, and I recommend having on your cheat sheet just because it's a good thing to have there in case you forget, which is that our stack is always going to look like this, where we have main variables, function, arguments, return address, prior EBP, and then function variables. And we can sort of identify these up here as well. So these two are main vars. Our function arguments are going to be this num kids. EBP and or old EBP or prior EBP are going to come from whatever the EBP was in main. And then our return address is going to come from the code. So that's what we're looking for here. And then our final thing is the function vars, which is going to come from the function. So that's just to help us identify what we need to have on the stack in what order. So we'll start with main vars here. And we're going to put that starting at EBP and building up. So we build the stack by reading the variables top down. And then putting them on the stack bottom up. So the first 4 bytes of this, or the bottom 4 bytes of this, are going to be dedicated to the first variable in main, which is children. And of course, we want to sort of identify what's supposed to be where on the stack for partial credit, just in case you get the value wrong. Here we're storing 3 into children, and so children is going to have in little endian order. 03 is the first box, 000000. We could say that there's garbage at the EBP if we want to. It's useful to denote that we don't actually care about what data is at EBP itself. So children's our first variable. The next variable is going to be refund. We might want to sort of hold off on filling out the value for refund for now, because it's going to come from understanding what happens in that function. So we can just sort of hold off on that for the moment, and not write anything there, but just note that that's what's going to be there. So that's refund. Function args is going to be the next thing that we put on the stack, and that is going to be num kids. And so we'll go ahead and mark off the next 4 bytes. And again, these are all 4 bytes because these are ints. So ints are 4 bytes. If it's char, it's going to be less data. So this is going to be num kids. And I'm going to mark that this is coming from children. Right, so it's copied from children. We see here that when we call tax credit, it passes in children, and that's what matches up with the function name tax credit and the parameter num kids. So we always have sort of an argument that's being passed into a parameter here. And so right now we can fill this out. We know what children is. It's getting copied in there, so we have 03000000 for num kids. Okay, moving upward, if we see from our sort of diagram down here, we had main vars, that was children and refund. Then we have function args, which is num kids. Now we're going to have return address. So the next 4 bytes, because this is an address, we always have 4 bytes for an address on this system. That's going to be the return address. To find this, we look at the code. So we see where the call is to tax credit. That's what we're looking for is when we're finding a return address is a call within the code. So we call tax credit. And then we want to return to the line that's the next line in the code. So the next line in the code is going to be this move instruction, which is happily right where I pointed to. And so that's going to be 0x08048382, just coming from looking for the call, going down one line, and looking at the address here. And so that's the address we're pulling out. Keep in mind that it goes in a little endian order, so the little end goes at the top box, so that 82 is in the top box, then 83, then 04, then 08. So that's our return address. Next up on our model of the stack is our prior EBP or old EBP. That's going to take another 4 bytes here. And so we're going to have old EBP. And that's going to come from our EBP from main. So this was main's EBP. We'll have a different EBP while we're in the function, but for now all we really need to know is that this is the value that goes in. Again, the little end goes first, so we're going to have 1C in this box, and then F3 in the second box, FF, and then BF, and that's our old EBP. Moving on, the last thing we have is our function vars. So function vars are the 2 variables that are defined in tax credit. We still sort of read from the top of tax credit down. So the first thing we're going to have here, the next 4 bytes, are going to be cash per kid. Here's where you'd want to use your handy dandy calculator to convert 3600 to hex. I'm just going to cheat using the solution and know that this is 0000OE10. But again, you should just be using your calculator for this at this point. It's not worth trying to do the conversion by hand here. And so that E10, again, little end goes first, so 10 OE 00 and then 00. And sorry for not being consistent about capitalization. It doesn't really matter in hex whether you're capital letters or not. And then we do int cash is num kids times cash per kid. So num kids times cash per kid is going to be 3600 times 3 is equal to 10800. Someone must have been thinking about tax season at the moment here when they were writing this exam. So we've got OX, and again, use your calculator to convert this. OX0000 2A 30. Again, little n goes first, so this is going to be 30 2A 0000. And that's what we have for cash. Okay, and that's most of our stack. We just have to fill in this one last blank, which is refund. And we see here that this function tax credit returns an int, and it returns cash. So we're passing the cash value back to the thing that we're putting it in when we called that function, and that's int refund equals tax credit. So when we have a function on the right-hand side like this, where it says equals tax credit, we're putting it into this variable refund. And so we're just going to copy exactly what we have for cash into the boxes for refunds. So 30 2A 0000. And that was a bit of a slog, but that's it for question number 4. So we're just, again, following this diagram, understanding where main vars, function args, return address, prior EBP, and function vars come from, and then converting everything into hex based on, what type of data it is. That's it for that problem.